In our last section of Chapter 2, we're going to look over solving linear inequalities. And for some background, take this in your notes there on the other side. Write x is less than 3, x is greater than 3, x is less than or equal to 3, x is greater than or equal to 3, and we're going to do 3 little number lines. Now in all these number lines, the number we're interested in is 3. So we can put that right in there. And what this will be useful for is to show you how to graph this inequality on a number line. Now, if it's less than 3, 3 is not included in the set. And we used to put a little hollow over 3 to indicate it's not included in the set. Now, x is less than, so we know it's going in a negative direction. So we put, to indicate that 3 is not part of the set, we put a parenthesis right there. We darken this line, and that's the graph of this inequality. Now, the major difference with these two is that here it's less than or equal to 3. So 3 is included in the set. And we used to put a solid dot there and then an arrow. Here we're going to use a bracket. Now in MATLAB they will give you multiple choice of these. They don't expect you to draw graphs, but they will expect you to do something else that we'll talk about here shortly. But this is the graph of less than. This is the graph of less than or equal to. Less than, just a parenthesis. Less than, equal to, a bracket. Now, if it's greater than, it's just a reverse parenthesis facing the other way. And greater than or equal to, a bracket facing right. Now, another very critical thing is interval notation. And once you've done the graph, interval notation works out very well. So what is out here? Well, we put a parenthesis, and it's negative infinity. That's what's out here. And this is going up to 3, but 3 is not included, so we put a parenthesis like so. So this, and copy this in your notes, this is the interval notation for this inequality, and this is the graph. And this one is very similar. It's coming from negative infinity, and infinity always has a parenthesis. We separate it with a comma, goes up to 3, but now to indicate that 3 is included, we put a bracket. And for this one now, x is greater than 3. It's coming from, and again, we're using a parenthesis right from the graph of 3, comma, and where is it going to out here? Positive infinity. Now, we usually put the negative sign to indicate negative infinity, and positive infinity we don't put a sign. And this one is similar. 3, and again, our 3 has to be with a bracket. I wasn't looking at my graph here. 3 is included, so we have a bracket, and this goes to infinity. Infinity always has a parenthesis. So we've done each of these in a graph and interval notation. So wherever you want to put these, we're just going to indicate the number we're interested in. This is why it's nice to do it this way. A -5, a 7, a -3/2, and this is a -2/5. Now, what I'd like you to do is take a moment and put the proper graphing of it there. So, did you get these? Now, in letter C, some students get confused, as I do also. So, they like to rewrite this inequality, putting the M on the left. Notice the point then goes toward the M, indicating M is less than or equal. And then the others are all in the fashion that we have. So let's write interval notation for these now. We can do it together. So a bracket, right from the graph, -5, comma, positive infinity. -infinity, comma, 7, parenthesis, right from the graph, -infinity, comma, -3/2, and right from the graph, a bracket. Again, from the graph, a parenthesis, -2/5, positive infinity. Infinity always has a parenthesis. Now, interestingly, when they do this in MATLAB, they often will give you the graph, and then they ask you to put it in interval notation. The graphs will be multiple choice. Interval notation you have to write. And I've seen students who had it correct in the graph, but didn't write it properly in interval notation. So take note of that. All right, I'm going to have to erase this, but you have it in your booklets. Now, there's one thing different in solving an inequality as compared to an equation. And let me show you the difference here. I'll write it out here. If we have 2 is less than 4, would you all agree that's a true statement? Okay. Now, if we multiply 2 by 2 and 4 by 2, we then get the statement 4 is less than 8. And that's true. But if we were to have multiplied this 2 by a -2 and this side by a -2, this would be a -4 and this would be a -8. And is -4 less than -8? And the answer is no. So whenever we multiply or divide by a negative, in order to keep our inequality true, we have to reverse the direction of our inequality sign to keep it a true statement. Now, as long as your variable is going to end up positive, then you divide by the coefficient. Positive, you don't have to worry about changing the inequality sign's direction. But if you're going to multiply or divide by a negative, in order to keep it correct, you have to reverse the signs. So put a big set of stars by this. This is the only difference. So now let's do some solving here. And they're written out. You can write them here or on the other side. We're just going to transpose that. So this is going to be x is less than or equal to 5. On this side, the 7 becomes a negative 7. And here, x is greater than. We're going to transpose that, becomes a positive 10, and this is 7. Now again, we want to keep our variables positive. So I'm going to transpose this, negative 5z. So a negative 5z on this side becomes a positive 5z. So this is going to be z. I'm going to transpose the negative 2. On this side it becomes a positive 2. So we have 1 plus 2 is 3. Again, I want my variable to be positive. Here, when I transpose it, becomes a positive 3x, so this is x. Don't have to change the direction of my inequality sign. And now I'm going to subtract 18 from both sides, or just transpose that, and I get on this side a negative 18, so this is a 6. So these weren't too difficult to solve, and now to graph them, I'll let you do that. Let's see what you get. We've given you the answers, put them on the number line, and also write the interval notation. We'll check your work. So these are the graphs. Now let's put it in interval notation. So it's coming from negative infinity, comma, 5, bracket. Starting at 7, 7's not included. Starting at 3, 3's not included. And coming from negative infinity up to 6, 6 is included. So again, whenever you see the inequality sign that's less than or equal, you're going to use a bracket. Some people also have noted that if you have it set up this way, the arrow in the inequality sign points to where the arrow in your graph will go. So here it's going to the left, here it's going to the right, here it's going to the right, here it's going to the left, as a little hint. Okay, and then practice, keep good notes in your homework log. Remember, you only have to change the direction of the inequality sign if you are multiplying or dividing by a negative. And I see that over here. We'll have to change the direction. So here we're just going to multiply both sides by 3. Here we're going to divide both sides by 3. Here we're going to multiply both sides by 8. Remember, 8 times 0 is 0, so. And now here we're going to multiply it by the reciprocal of 3/5, a negative 3/5. So this reciprocal will be a negative 5/3. So we're going to multiply this by a negative 5/3 and also reverse the inequality sign. So let me give you a few moments to solve these and put our values on the number line and graph them. And then we'll do interval notation together. Okay, we've solved them. This is an improper fraction. Changing it to a mixed number is this, but I would accept this, and depending how they want it. So to put these into interval notation now is negative infinity to negative 24 and a bracket. Again, if it's an equal sign there included in the inequality, a bracket. Only the inequality, no equal sign, a parenthesis. So this is negative infinity to 24 and 1/3. This would be a parenthesis, 0 to positive infinity. And this would be a bracket, negative 15 to positive infinity. Now notice the inequality sign originally was less than, but this was negative. So multiplying it by a negative to keep it true, we had to reverse the direction of our inequality sign. Okay. Now, depending on the class time available, we're going to have you work these out. I will do them. Notice they're not asking us to solve them, just to find the inequality value. Okay, we can pause it here. Look at your work. Hopefully you know this would have a parenthesis, this would have a bracket, parenthesis. I noticed in the answer key in your booklet, they have a positive 7/5. I believe it's a negative 7/5. So that was a little error we discovered. Okay. Now, up to now, we've been working with simple inequalities. Here, these are compound inequalities. There's two sets of inequalities with a variable in the middle. So the strategy for solving these, again, is just to isolate the t, or the variable. This one's already isolated. So when we go to graph it, we're going to put our numbers that we're interested in, a -5 and a 0. Now t is in here in the middle. So what's this symbol? Well, a parenthesis. And what's this symbol? A bracket. And we darken it in between. Now, how would you put that in interval notation? Well, right from the graph. -5, comma 0, bracket. Now for letter B, again, to isolate the x, we're going to divide this term by 2. Then we have to do it to everything else. So this becomes a -6 is less than or equal to x is less than -4. So the numbers we're interested in are a -6 and a -4. And here we're going to use a bracket. And here we're going to use a parenthesis. Fill it in. And then putting that in interval notation right from the graph. Now here we have to get rid of the 9 first. So we add 9 there, add 9 there, add 9 there. This becomes 12 is less than or equal to 4x is less than or equal to 16. Now to get rid of the 4, we're going to divide each term by 4. So this is 3 is less than or equal to x is less than or equal to 4. Numbers we're interested in is 3, 4, and these will be brackets. And interval notation is bracket 3, comma 4 bracket. So not too bad, and again giving us lots of practice of solving equations. The only thing is, if we ever had to divide by a negative, we'd have to reverse the direction of our inequality signs. And we have a little word problem here. 8 more than twice a number. Well, twice a number plus 8 is less than negative 12. So we go 2x, transpose this, makes it a negative 8 there, so this is a negative 20. Divide both sides by 2. We get x is less than negative 10. And that's the answer. All right, our last. Now here we need a triangle. And again, it doesn't have to be proportionate, just so we can put some values there. One side of the triangle is 6 times as long as the other side. Well, this will be the other side, and this is 6 times as long. And the third side is 8 inches. And it can be no more than this. So find the maximum length of the other sides. Well, we're looking for x. So x plus 6x plus 8. Now maximum length. So it would have to be less than or equal to 106. That's the inequality you end up with. So we have 7x. We're going to subtract 8 from both sides, and that will give us 98. We're going to divide both sides by 7, so we have x is less than or equal to 14. So that's our basic answer here. And if we go 6 times 14, 6x is less than or equal to 84. And those are the answers we find below. Okay, now we do have a practice test for Chapter 2. It's actually in 2 parts. One dealing more with equations, the other one, Part 2, dealing more with word problems. And if you have time, this is in your booklet, and I have a video, and hopefully I'll put the link here so you can have it easily found. All right, well, good luck on your test.